So we have now talked about 4 different gas laws: Boyle's law, Charles' law, Gay-Lussac's law, and the combined gas law. Remember, when I am changing pressure and volume only, then I have Boyle's law. If I'm changing volume and temperature only, then I have Charles' law. And if I'm changing pressure and temperature, then I have Gay-Lussac's law. If all 3 variables are being changed, then I have the combined gas law. Notice also that in this table it shows N. That simply represents the number of moles. So what this is saying is I am changing, for example, for Boyle's law, pressure, volume, but I'm not adding any more gas. I'm simply changing pressure and volume. I'm not changing the number of moles of gas I have. So I think the hardest part about these problems is figuring out which gas law you're dealing with. And so in this review, what I'm going to do is I'm going to have you simply read a question and identify what gas law you should use to solve the problem, to answer the question. If there's a star next to the number, then I also am asking you to solve the problem. All right, so let's look at number 1. It says a balloon has a volume of 1.2 liters inside a room where the temperature is 25 degrees Celsius. So this would be my V1, this would be my T1. What is the volume? So it's asking for what is the new volume, so V2, of this balloon when it is taken outdoors on a very cold day where the temperature is negative 15 degrees Celsius. So that's my T2. So notice the only 2 variables I'm changing are volume and temperature. And so the gas law that you would use to solve this problem is Charles's law, which is simply V1 over T1 equals V2 over T2. And I'm not asking you to solve this one, so you don't need to solve it, you can just identify what it is. All right, number 2, if I have, and I am asking you to solve this one, by the way. If I have 2.9 liters of a gas at a pressure of 5 atmospheres and a temperature of 50 degrees Celsius, what will be the temperature of the gas in Celsius if I decrease the volume of the gas to 2.4 liters and decrease the pressure to 3 atmospheres? So this is my V1, this is my P1, this is my T1. This is my new volume, my V2, and my new pressure, P2. So notice I'm changing all 3 variables because my temperature is what I am solving for, my T2. So for this one, I'm going to use my combined gas law. I'm changing all 3 variables. Okay, so P1 times V1 all over T1 equals P2 times V2 all over T2. And now I'm simply going to plug in my value. So 5 atmospheres is my pressure. My V1 is 2.9 liters. My T1 is in degrees Celsius, so I need to convert that into Kelvin. So 50 plus 273, I get 323 Kelvin. Okay, that equals, okay, my P2 in this case is 3 atmospheres. Okay, my V2 is 2.4 liters, and I'm solving for T2. Okay, so I need to cross multiply. I'm going to be solving for my T2. Okay, so 5.0 times 2.9 times T2 gives me 14.5 times T2. That equals, okay, 323 times 3 times 2.4. I get 2,325.6. Now I'm going to divide both sides by 14.5 to get T2 by itself. Okay, and the value that I get unrounded is 160.39. Now keep in mind this is in Kelvin, but I want to be in degrees Celsius. So remember, since Kelvin is Celsius plus 273, to convert this Kelvin into Celsius, all I have to do is subtract 273 from it. And what I get unrounded is negative 112.6. Keep in mind, since my last step is subtracting, I need to round based on decimal places. 273 has no decimal places, so my final answer simply needs to be rounded so it has no decimal places. So negative 113 degrees Celsius. All right, let's look at the last two problems. It says a sample of nitrogen gas is in a container with a variable volume. When the volume of the container is 0.50 liters, so V1, the pressure is 6 atmospheres, my P1. The volume of the container is changed to 2.5 liters, so its volume is increased, keeping the temperature constant. What is the new pressure of the gas? So that's my P2. So since I'm simply changing my pressure and my volume, but I'm keeping temperature the same, this will be Boyle's law. That's what I need to use in order to solve this problem. But I don't need to solve it, so we're all good. All right, last practice problem. The temperature of a gas in a 10-liter container at 0.985 atmospheres, so that's my P1, is 2.5 degrees Celsius, T1. What is the pressure of the gas after the temperature is raised to 105? So that's my T2. Notice this 10 liters here is simply a red herring. I don't need that information because the volume of the container or the volume of the gas is not changing. So since I'm just dealing with pressure and temperature changing, then I have Gay-Lussac's law. All right, so P1 over T1 equals P2 over T2. Okay. My initial pressure is 0.985 atmospheres. My T1 is in currently degrees Celsius, so I need to take 2.5 and add 273 to that. And so I get 275.5 Kelvin. All right, my P2 is what I am solving for. And then my T2, my temperature increased to 105, so 105 plus 273, I get 378. I'm going to cross multiply. All right, so what this tells me is 275.5 times my P2 equals, so I need to take 0.985, and I need to multiply it by my 378. And what I get is 372.33, and now I'm going to divide both sides by 275.5. Okay, and so my P2 that I get is 1.3515. If we look at my values, 0.985 has 3 sig figs, 275.5, it should actually be 276 if I'm looking at the correct rounding based on decimal places, but that would be still 3 sig figs, and 378 has 3 sig figs. So 1, 2, 3. So my final answer will be 1.35. And notice the units for this, since the pressure is in atmospheres here, the units for pressure here will be in atmospheres as well.